Let's now learn about some more mathematical operations and also about rounding numbers. And we have already been using lots of mathematical operations. For example, plus, minus, times, divided, exponentiation, and so on. And so we don't need to go over these again. So let's start here with the square root. And so just like many other functions, the square root is part of the math namespace. So math.sqrt. So this stands for square root. And so all we need to do is to pass in the number, and then it will give us the square root. And the same could be achieved using the exponentiation operator as well, by doing 1 divided by 2. And so that 2 is the square. So we want the square root, so we use 1 divided by 2. And actually we have to put this into parentheses, and now it works. All right, and the same would work for a cubic root, for example, of 8, which would be 2. And so actually this is, I think, the only way you could calculate a cubic root if you need it. Next up, let's get the maximum value of a couple of values, okay? So again, we use math and .max this time. So let's just use a couple of numbers here. And so, as the name says, the maximum value gets returned to us. And this max function here actually does type coercion. So it should now still give us 23, okay? However, it does not parsing. So if we try 23 pixels, for example, it will then result in not a number. So this does not work. All right. And just as we have max, we also have min. Let's just put it back to 23. And now here we get 2. All right. Now, besides a couple of methods, there are also constants on the math object or on the math namespace. And so, for example, if we wanted to calculate the radius of a circle with 10 pixels, we could do that. So for that, we use math.pi. And for now, let's just take a look at that. And so it is this constant that you might know, probably. And so again, let's say that we get like 10 pixels from the user interface. So we can say parse float of 10 pixels. And then we simply have to square this value. This is how we calculate the area of a circle with this radius. All right. Now, another thing that is on the math object is the random function that we already have been using a couple of times. And it's very important to be able to generate good random numbers when we need them. So before, we have already created random dice rolls, remember? So that we did by math.random. And so this will give us a number between 0 and 1. So as I reload, you see I get different values. Then we multiplied this by 6. And then we removed basically the decimal part by doing math.trunc like this. Okay. Now the problem with this was that then the highest number could be 5. And so we simply added +1 to offset that truncation here. So that cutting off of the decimal part. And so now we're going to get values here between really 1 and 6. Okay, so this works great, but let's now generalize this formula into a function that we can then use as a random number generator. And this is going to be super useful in many apps that you're going to build throughout your career. Now, there is actually a problem with the implementation of this function in the first version of this video. And so you will see my screen change now because I re-recorded this part of the video later. But that's not a problem at all. And so let's now just start working on this random number generator. So we're going to create a function. Let's call it random int. And here we will pass in a minimum and a maximum value. So minimum and maximum, because we basically will want to generate a random number between these two values. And let's actually once again first call this function so that we actually see how we can use it. So for example, let's say we want a random number between 10 and 20. And so then this is how we would call this function. Or maybe we just want a random number, so a random integer between 0 and 3. And so these are all the different ways in which we'll be able to use this function. And so let's now actually build out this function here step by step, because this will teach you a lot about random numbers and how to generate them. So as always, let's start from math.random, which, as you already know, will give us a random number between 0 and 1. Now, if we wanted to scale this, so basically if we wanted to have a number, for example, between 0 and 2, then we would multiply this by 2. So let's actually do that here first in order to understand how this is going to work, even though we already did this here many times before. So now we have with this here basically a number between 0 and 2, but it's not quite 2. It's more like between 0 and 1.999999, right? Because keep in mind that these are not integers. These are basically decimal numbers. And so now we will, before we can move on, actually take out the decimal part with math.floor. So basically rounding down this value. And so with this, we will now always get a number which is either 0 or 1, because again, this one here will stay between 0 and 1.99999 and so on. And so if we take off that decimal part, we will end up with 0 or 1. So with this right now, we can generate two different random numbers. And that's because we have this two right here. But of course, this needs to be dynamic. So it needs to respond to the minimum and maximum values that we input here. So here, for example, we do not want only two possible random numbers, but really 10, or actually 11, because this minimum and this maximum should also be included. So if we count from 10 to 20, that will actually be 11 numbers. Or here, it will be 4 numbers. So 0, 1, 2, and 3. So 4 numbers, right? So how can we get to these number of values that we want? Well, here, instead of hard coding this value, we just need to subtract the max from, or actually the other way around. So subtracting the minimum from the maximum. So in this case, that would give us 20 minus 10 is 10. And then here we would get 3 minus 0 is 3. Just remember that actually here we had not 10 different random numbers, but 11. And here not just 3, but 4. And so again, that's because both the minimum and the maximum should be part of the range. So to fix that, all we need to do is to add +1 here. All right. And so with this, what we have at this point will already give us the correct number of possible random integers. Now we're not done here yet, but let's already start to log the result here to the console of this one, just so we can see that we're on the right path. So let's get rid of this one here. So it's just this last result here. So if we keep updating, then notice how, of course, these numbers are not between 10 and 20 yet, but really more between 0 and 9, or probably 0 and 10. So if we reload this a few times, we should get all of these different numbers. So again, between 0 and 10, with both of these values included. So let's fix that. And so basically that's going to be the second step. So we already did the first step, which was basically to scale up this math.random, which initially is a number between 0 and 10, all the way to making it dynamic taking into account our minimum and maximum. And so after this first step, now the possible number of random integers is correct. But now we need to basically then shift this range to the correct place. So basically that it can start not at 0, but really at 10 here. So all we need to do is just what I just said. So basically adding this value right here so that the range starts there. So here at the very end, so after all of this calculation here, we just add the minimum value. And so, beautiful, 19 is indeed between 10 and 20. And if we reload this a couple times, then you see here that now we already got the max value. So that's nice to know that it is indeed included. And it would be good to also get a 10 here just to make sure. But well, I'm not going to reload it a million times until I see it. But I'm sure that this is working just fine. Let's also maybe duplicate this here and try one between 0 and 3. And so this should be easier to get all of them here at least once. So you saw that we got a 3 before and a 2, now a 0. And so that means that our random int function here is absolutely correct and ready to be reused in any of your future project if you ever need some random number between two values. Now, as I change my screen back to the original, you will see the old incorrect implementation of this function. So please just disregard that function that you see on the screen now and use the one that we just coded earlier. Okay, next up, let's talk a little bit about rounding, and let's start by rounding integers. So you can add some comments to this here if you want, but I'm just going to leave it like this. I will just add here rounding integers. And so we have already been using math.trunc, right? So what this does is to simply remove any decimal part. And so we end up with 23 here, right? Let's just take this one out. All right. So again, this one simply removes any decimal part always. But we have also other ways. So we also have round. So math.round. And so this one will always round to the nearest integer. So this one is going to be 23 and the other one 24. Let's duplicate this a couple of times to save us some time. Then we also have ceil. And this one will basically round down. So both of these results should become 24. And so that's these two here. So line 318 and 20. Or actually, it's these two. So I'm confusing these numbers. All right. So both of these are 24 because they will both always be rounded up. And then we also have a floor. And so these two will both be rounded down to 23. And so that's what we get here. And by the way, all of these methods, they also do type coercion. So if we do this, then it's going to work just the same. Now you might think that floor and trunc are very similar. Let me just put this one down here. And indeed, they do the same when we are dealing with positive numbers. So basically, floor and trunc both cut off the decimal part when we are dealing with positive numbers. However, for negative numbers, it doesn't work this way. So let me compare them here. So trunc minus this and also floor. Okay, and so now this one here, just like before, gets truncated. So it simply removes this part, but floor now gets rounded to minus 24, because with negative numbers, rounding works the other way around. And so actually, floor is a little bit better than trunc, because it works in all situations, no matter if we're dealing with positive or negative numbers. And so here, let's go ahead and replace this with floor. So we're looking for a really generalized function here. So this random int function should work in all situations, even if we give it negative inputs here. And so therefore, we need to work with floor here. All right. So that's rounding integers. Let's talk about floating point numbers. Or we can also say decimals. And now with decimals, it works in a little bit different way. So let me show you how. So in decimals, we have to specify the number like this in parentheses. And then on that number, we call the toFixed method. Okay, and let's try it here with 0 first, just so we can see the result. And so you see that with 0, it is converted to 3. But this 3 is white here, while these other ones are pink or purple. And so this means that is actually a string, right? So toFixed will always return a string and not a number. And that's important to keep in mind. So if we set here instead of 0, the 3, then it returns 2.7 and it adds zeros until it has exactly 3 decimal parts, just like we specified here. All right. Now let's add something more here, like 2, 3, 4, 5. And let's say we only want 2 decimal places here now. So this should become 2.35. And indeed it does. Okay. And if we now wanted to convert this result to a number, then we simply would have to add the plus sign here. And then we already know that this here converts a string to a number. And indeed, now it is purple again. So with decimals, it works differently than with integers. And that's once again because things in JavaScript evolved kind of in a weird way in this kind of old language. And if the language was designed today, definitely this would be very different. But yeah, this is what we have to work with right now. Okay? Just keep in mind that this here works in a similar way than the string methods. So this is a number, so it's a primitive, right? And primitives actually don't have methods. And so behind the scenes, JavaScript will do boxing. And boxing is to basically transform this to a number object, then call the method on that object, and then once the operation is finished, it will convert it back to a primitive. Okay? All right. So once again, this lecture looked a little bit like a reference of a couple of different methods. But to make it a bit more fun, let's now apply some of this to our Bankist project. And the first thing that I want to do is to round the requested loan amount. So this one here. So this looks weird. Oh, it's because of this number. Okay. So we could use this application in this other page here on the other side, but I prefer to have everything here in one screen. But anyway, I can take a loan like this, right? With the decimal part. But in practice, I've never seen a bank giving out a loan like this. And so let's apply the rounding to the loan functionality. So that's here. And the rounding then needs to happen right here. So the value that we get from the loan here needs to be rounded down. Okay? And then we actually do not need to convert it to a number because, as I showed you before, the math.floor method actually does type coercion itself. Okay? And we are using floor here because we simply want to round any value down. All right? So in this case, it would have been 150. And that's it. So let's try that again now. So let's ask for 150.56. And so now we get just this. Okay, Probably I added one more 0 there, but that doesn't matter. Next up, let's use the toFixed function or method to make our numbers here look a little bit nicer. So here, for example, we have this decimal part with the 2 numbers, but here then we only have the 0.9. And so this should be like 0.90. And here it should be 1300.00. And the same also up here. All right. So for that, we can use the toFixed function that we just learned about. And so let's do that in all the places where we display numbers on the screen. And so that's in these 3 functions. So display movements, display balance, and display summary. So let's start here at the top. And so here we have the first occurrence. So this movement here is a value, so it's a number that we display. And so on here, we can simply call, so dot to fixed, and then with 2 decimal parts. All right. And now let's just copy this from here. So display balance. So let's do the same here. And the same in the summary. And so that will then hopefully also fix this weird, really long number that happens because of the rounding errors in JavaScript that I just explained to you in the previous lecture. So everywhere we print a number, I will do this now. So, okay. Then also on this result and also on the interest. Let's give it a save. And that's a lot better. So it worked. You see, now we get 0.00. And here we also get nicely 0.90. And the same down here. We are now back to having just 2 decimal places, just as we requested, so to say. So this lecture was kind of a short overview of some more math functions, including some rounding and also some other stuff like getting the max and the min value. And yeah, so good to know functions. And of course, there are a lot more. So if you need something like logarithmical functions or sinuses, then of course you can always check out the MDN documentation.